in the case when you're talking about the multiplicative factors as regards probability. So let's just quickly look at the question here. Let's say a bar contains 5 red and 7 blue balls, identical balls. Okay, so a ball is selected at random and replaced. Then a second ball, was selected. Now, our question is determine the probability that they are 1, both red balls, 2, both blue balls, 3, 1 red and 1 blue. Then let's say 4 red and blue in that order. All right, so this is the question, and the question we're looking at. So a bag rather, contains 5 red and 7 blue identical balls. So a ball is selected at random and replaced. Then a second ball was selected. Now determine the probability that they are the two balls you picked, because you picked one first and then replaced it, like you kept it back, then pick the second ball. Now find the probability that the two balls, they are both red, they are both blue. Number 3, one is red and the other is blue. While number 4, one is red and the other blue, in that order. So we've talked about this before, what in that order means. So now first thing we do is you have to get the total possible outcome. Possible outcome would be the 5 red plus the 7 blue. So we have 12. The total number of balls, that's 12. That would be the possible outcome. Now, this will lead us, this is a multiplicative law because both you're picking twice. You pick the first time and then you're picking the second time. So this obviously is a multiplicative law. Now we'll have to draw a tree diagram, just like you draw an outcome table the other time. Now you're drawing a tree diagram for this. Remember, 5 red and 7 blue. So please look at this so that so the first time you picked, this is a tree diagram. So we can say that this is red and this is blue. So this is for your first pick. The first time you pick, probability of picking red should be 5 over the total possible outcome, which is 12. Then if you are picking blue that first time, there are 7 blues over 12. This is for the first time you picked. It is either you picked a red, which is 5 over 12, or you pick a blue, whose probability is 7 over 12. Now, the question says that after picking that first time, the first ball, it was replaced. You replaced it, and then a second ball was picked. Meaning, after you picked the first ball and you've seen whatever outcome it was you got, you put it back in the bag. Then before picking the second ball. So this tree here, this is the first time. Then since you're picking a second time, this one gives out two branches, and this also gives out two branches. Okay, so at the top here you would have the red, this is still blue, this is red, and this here is blue. So if you picked red the first time and you had to keep it back in the bag to pick again, it means that probability of picking red again, that's here, um, probability of picking red again would still be 5 over 12. So this is the second time. The first time, that is the first tree. The second pick, that's this other one now. So if you picked red the first time, picking red the second time would still be 5 over 12 because you replaced that ball back. Then picking a blue will be 7 over 12. Then now for the other one, picking a red, you still have 5 here. This is too congested. This is too congested. So let's say red, blue. So picking red here, still 5 over 12. And then picking a blue here is still 7 over 12. So this is because after picking that first ball, you replaced it. After picking the first ball, you replaced it. So the first time you picked, that is this part here. This part here is the first time you picked. So picking red will be 5 over 12. Picking blue will be 7 over 12. Then since you're picking a second time, that's this other one you have at the front. Remember, you replaced that first ball, so the total remained 12. So picking red again, still 5 over 12. Picking a blue, 7 over 12. Picking red at this other part, when you picked blue the first time, picking red is still 5 over 12 because you replaced that first ball. And picking blue is 7 over 12. Now, if you're asked for probability that both of them are red, then you're looking at this part. This is the red. You see it there, probability of picking both red. Then if you're asked for probability of picking, the first is red, second is blue. That's this place here, red, blue. So this is red, blue. Then if probability of picking, the first is blue, the second is red. That's this. That's the first is blue, the second is red. While lastly, probability that then both of them are blue, then you would be looking at this part. The first is blue, the second is blue. Okay. Do you guys understand this first part? We're not start calculating. I'm just showing you how to draw the tree diagram, mainly for why. Do you guys understand this first part? Okay. All right. So remember that second part is the first time you're picking, and then the first ball, after picking the first ball, it was replaced. So meaning the total of 12 still remained before picking the second ball. So that's how we got picking it red the second time with 5 over 12. Then if it was red, you picked the first time, picking it blue, 7 over 12. If it was blue, you pick the first time, picking a red, 5/12. If it was blue, you pick the first time, picking a blue again, 7/12. So please take note that you shouldn't expect this direct question in your in the theory part of your exam. So those of you writing WAEC for the GCSE, and sometimes your questions are actually not so complex. Sometimes, so possibly you can see a question like this, but for WAEC, you shouldn't even expect to have a selection with replacement. You shouldn't expect it in even your objective questions. What you have is selection without replacement. That is the part that is a little bit complex. But so we'll get to that. I'm just trying to introduce it from this part. So now we'll go back to the question, the part where they said probability that the both balls are red, that both of the balls, the first pick and the second pick, that they are both red. So if we're looking for probability of both red, then it is this part here. Um, Probability of both red, then look at red and red here. Red, that's the purple, the part I circled purple. So it means that probability that the both balls are red for number one, you have to say 5/12 times 5/12. 5/12 times 5/12. So probability of picking, oh, red, both are red and red will be 5/12 times 5/12, and this result would be 25/144. That's probability that the first is red and the second is red. So once you see in probability and, that's multiplication, it means you're multiplying times. So probability that the first is red, the second is red. That's what probability that the both of them are red. That's what it means. So red and red, you can see there from the tree, 5/12 times 5/12. Then you get that result. Does everybody understand how I got that? Okay. All right. So probability that next is probability that they are both blue balls. So I won't be doing this. Probability that number two, probability that they are both blue balls. So let's start. Oh, Christine, probability that they are both blue balls. So you can see from here. So what should we do? Christine, this is your question. Number two.
Times 7/12 and 7/12.
Okay, probability that they are both blue balls. Let's use another color. Both blue balls, you can obviously see here that this is the blue balls, blue and blue. That's the part circled in the blue color there. Probably that they are both blue balls, BB. That's the first one is blue, the second one is blue as well. So that's 7/12 times 7/12. So here we should have 7/12 times 7/12, and that should be 49/144. That's probability there that they are both blue balls. Then we proceed to number three. Number three says probability that one is red and the other is blue. probability that one is red and the other is blue. So if you look at the tree diagram, you will see that it's very obvious that there are two cases where we have a red and blue together. Look at number three. Find the probability that one is red and the other is blue. So there are two cases we have red and blue together. So if you're told to find the probability that one is red, um, probability one red and one blue, then there are two situations where that happens. You see there, you have red before blue, and you also have blue before red. So probability that one is red and the other is blue has to be maybe the first was red and the second was blue, or the first was blue and the second was red. So take note of this. You will see that this number three and number four looks like they are the same, but they are not. Number if the question comes in the form the way it is in number three, then you know that it is complex. It's a combination of multiplication and addition laws in the probability. But if it comes in case of number four, one red and one blue in that order, it means that the first is red and the second is blue. So you don't need to say or, no. The first is red and the second is blue because it said in that order. We've done something like this before. So one red and one blue for number three, it is either the first, for the one red and one blue, it is either um, it should be the probability that it was red before blue, or probability that it was blue before red. And or means plus. Or means plus in probability. So when you see or, it means that you're actually adding. So let's get the probability for red and blue first. So for red and blue, you see it's 5 over 12 times 7 over 12. Look at it there, red and blue. Let me circle it with, I'll circle it with green, red and blue. This is red and blue, circled in green. Probability that the first is red and the second is blue. That's the part circled in green. So 5 over 12 times 7 over 12. So come here. Since it is one is red, one is blue, we said it's either it's the probability of red and blue or blue and red. So for red and blue, we got 5 over 12 times 7 over 12. Then all means plus, so I have to say plus. Blue and red, oh, 12. Then blue and red, we'll go back to check for blue and red. Who can tell us the two numbers to multiply for blue and red? Christine already answered the question, so let me look for. Um, Winner, can you hear us? Winner, can you hear me? Oh, all right, Lucas.
Yeah.
Okay, Lucas. So we're looking for the two numbers, the two fractions rather, to multiply for blue and red. And what should be those two fractions?
7/12 times 5/12.
Okay, so 7 over 12 times 5 over 12. So here we're saying for blue and red, 7 over 12 times 5 over 12. So for this first part, to have 35 over 144 plus, so that plus is coming from the or, because probably that one is red, one is blue. There are two times you have a mixture or a combination of red and blue. So it's either the first was red, the second was blue, or the first was blue, the second was red. That's where the or is coming from. And or means plus in the probability. Y and the mix times. So that's why we have that. So for this first part, to have um, 35 or 144, then at the other side, we still have, on the other side, we still have 35 over 144 as well. So this is 70 over 144. When you divide, you should have 35 over 72. Yes. So 35 over 72, that should be the probability that one is red and the other is blue. One red and one blue. So that's the result there. Then for number 4, you see, find the probability that one red and the other
Sorry,
blue in that order.
sorry, isn't it supposed to be 288?
Sorry?
The answer there, the 35, is it not 288?
Oh, oh, no, no, no. When you're adding fractions, when the denominators are the same, you make if the denominators are not the same, you try to make them the same. But if the denominators are the same, all right, don't worry. Let's quickly look at this. Um, 3/5 plus 2/5. What's the LCM? That's how you know. How do you add your fractions? You look for the LCM first. Is that how you know to do it? Lucas, can you hear me?
Yeah, yes, sir.
How do you add your fractions? Do you use the LCM method to add your fractions?
Yes,
Okay, so look for the LCM of the denominator. It's 5, right?
5
5
over
divide 5, 1. 1 times 3, 3. Plus 5 divide 5 and 1 times 2, 2. So you have 5/5, which is 1. You understand?
yes, sir.
Okay, so that's why that is 144 at the bottom. Because when you look for the LCM of the denominator, it's 144. Do you understand now?
Yes, sir, yes, sir.
Okay. So then for the last part, please remember, like I've told you, this isn't attainable in your theory. Do not even put hope there at all. This is just the foundation of something we're supposed to do. That's without replacement. That's where you should be expecting to see such question. So, but with replacement, it's too straightforward. I am so certain you can see that. So, for number 4, one red and one blue in that order. In that order means in that arrangement. So that's to say that the first one is red and the second one is blue. So if you're doing that, then you are taking only red and blue. You don't have to say red and blue or blue and red. No, you don't have to say that because you've been told that in that order, meaning first is red, the second is blue. So that means what you're doing, you're taking red and blue alone. That is 5/12 times 7/12 for red and blue alone in that order. So 5/12 times 7/12 from the tree diagram. So do you guys understand this? Okay. Winner, what about you? Yeah, Christian, I see you. Oh, okay. Winner isn't responsive. All right, now to the actual question. To the actual question. We are taking
I can't see
this.
it.
Okay, if you can't see the screen, if you can't see the screen, winner, you would have to leave the class and come back in. It's from your hand. You have to leave the class and come back in. All right, now to the actual question. This same question. There's 5 red balls and 7 blue balls. Here we say that a bar contains 5 red and 7 blue identical balls. A ball is selected at random and replaced, then a second ball was selected. Now I'll change this question. I think I should just copy it. Um, okay, copy. So we'll change this question and see. So here we say the ball is selected at random. Okay. Okay. Without without my without replacing the first ball, so without replacing that first ball, a ball was selected at random. Without replacing that first ball, a second ball was selected. So let's see how this would be. Let's see how this would be different. So this is the pattern of question you should hope to see if you are open to looking forward to solving questions relating to probability, which definitely you'll be seeing, but we do not know in what form it will come. But this is just an actual recurring question, though. And this is especially for the white and echo syllable of this particular question. So now, a bar contains 5 red and 7 blue identical balls. A ball is selected at random. Without replacing that first ball, a second ball was selected. Now determine this probability and whatever. So first thing we'll do, we have to draw the tree diagram for this without replacement. Okay. Let's see. It increases font. Okay, so the first red, blue. So remember, this is the first time you're picking. The first time you picked, you still have a total of 12. So picking a red is 5/12. And picking a blue is 7/12. Now, if there is a second pick, which of course there is, so you have another branch here, and here too you have another branch. So this is still red, blue, red, and blue. Okay, now listen. The first time you picking a red, well, the probability was 5/12. Now, without replacing that first ball you picked, you did not put it back in the bag. You didn't put it back. So automatically, the total number of balls you have in that bag has dropped by one because I said without replacing that first ball. So automatically, if you did not replace that first ball, total number of balls in that bag is no longer 12. It is now 11. So your possible outcome has shifted to 11. Now you picked a red the first time. I'm sorry, my earpiece has just gone off, so I'll try to put this on speaker. Okay. So now you picked a red the first time, that's 5 over 12, and you did not replace that ball back. Then the probability that you will pick a red the second time would, your number of red must have reduced by one because you picked a red the first time, 5 over 12. The number of red must have reduced by one because you didn't put it back. And the total number of balls in the bag has also reduced by one because you didn't put that first one back. That's 11 now. So probability that you will pick red a second time will be 4 because the red has dropped by one since it was red you picked the first time. You see here, um, so you picked red the first time. So the total number of red you have now, since you didn't put it back in the bag, has dropped to 4. So probability of picking red a second time is now 4 over your total number of balls in the bag has also dropped to 11 because you didn't put that first ball back. So look at this first part. Do you understand what I just said? Okay. Then we'll come to this other one, the one at the bottom. So if it was red you picked the first time, probability that the second time you will be picking a blue, probability that the second time you'll be picking a blue, remember you have not picked any blue before. It was red you picked the first time. So your blue still remains the 7, the original 7. Look at what we're looking at. We're looking at this part. We're looking at this presently. We're looking at this part. This is the first pick. So this is picking that part circled red. It means that the first time you picked was a red. The other one at the bottom, that blue, that one says the first time you picked was a blue. So if the first time you picked was a red, probability of picking red a second time, your red has reduced to 4 since you didn't put it back, and the total has dropped to 11. Now, since you picked red that first time, probability of picking a blue the second time, your blue has not been touched. Your blue still remains 7. But that red you picked the first time, you didn't put it back. So over 11. But your blue remains 7 because it was red you picked the first time. It was red you picked the first time. So your blue hasn't been touched. Your blue remains the 7. But since you didn't put that red back, that red you picked the first time, the total is 11. Do you understand how I got 7 over 11? Okay. All right. So we are done with the part that it was red we picked the first time. So let's go to the second part. If it was blue we picked the first time. So if it was blue we picked the first time and we did not replace it back, then picking a blue the second time, our blue must have turned towards red rather. So if it was blue we picked the first time and we didn't replace it back, so probability of picking a red the second time, look at answer the last question. Christine, if it was blue we picked the first time, probability of picking a red the second time, remember we did not replace it. So probability of picking a red the second time and it was blue we picked that first time. What would that be? Christine. Christine, can you hear me? Okay. All right.
4.
Probability of picking a red the second time, if it was blue we picked the first time, would be what? We're waiting.
6 out of 11.
There are only 5 red. Look at the parts we're hoping to get now. This part was here. This part there I colored with the black pen. That's what you're looking at. So if it was blue you picked the first time, that's 7/12. You see blue. If it was blue, that first part is what you picked the first time. If it was blue you picked the first time. What is the probability of picking red the second time? Okay, Lucas, do you want to try? 5/11. 5/11. So, Christine, listen. You picked blue the first time and you did not replace it back. It means that your red has not been touched. See, when you're dealing with each of them, you deal with them independently. You see that first part we just finished? That first part says it was red you picked the first time. So if it is red you picked the first time, picking a red the second time, since you didn't replace it back, red has dropped to 4 and the total has dropped to 11. That's 4/11. Then at the bottom, it says if it was red you picked the first time, then picking a blue the second time, the blue has not been touched because it was red you picked the first time. So picking a blue the second time, your blue remains the exact 7 over the total, which has dropped to 11 since you didn't replace that your first pick. So that was our first part, saying that if it was red you picked the first time. Now this second part is saying that if it was blue you picked the first time. So if you picked blue the first time, probability of picking red the second time, your red has not been touched. Do you understand, Christine?
Yes, sir.
So your red has not been touched if you picked blue the first time. Your red has not been touched. So the red still remains 5. Um, the red still remains 5, but the total has dropped to 11 since it didn't replace the first one, the blue you picked the first time. So now you will try this again. So if it was blue you picked the first time, what is the probability that you pick blue the second time? That's this last place now. That's what you're looking for. This last place now. You picked blue. You can see it. You see it there. You picked blue the first time. You picked blue the first time. So what's the probability that you pick blue a second time? Christian, that's your question. Because you got the first one wrong. What
6 out
number?
of
What?
11.
Okay, 6/11. So you see, here it would be 6/11. So basically, you're dealing with them independently. I'll have to go back to this, to the starting. I have to go back to this. So I'll try to cut this part out. I'll cut that other part out. Forget about that other part. Let's look at only this part. Yeah. So basically, it is saying that if it was red, if it was red, that's that part circled purple. If it was red, you picked the first time. Because picking red the first time will be 5/12. Yeah. So if it was red, you picked the first time and you didn't replace it back, then picking red a second time, your red has dropped to 4 since you have already picked one out, and the total has dropped to 11 since you didn't replace that one you picked, 4/11. Then look at this one at the bottom for the blue. It says that if it was red you picked that first time, then probability of picking blue a second time, your blue has not been touched. Because look at it, it was red you picked the first time. So your blue has not been touched. So your blue remains 7, but the total will no longer be 12 since you didn't replace that red. So over 11. Then now when you come to this other side, it says that you also have to cut that that part out. So this other part is now saying if it was blue, you picked the first time. So when you're doing this, you're doing them individually, you don't combine them together. So if it was blue, you picked the first time, it was 7/12. Then picking red a second time, since the first pick was a blue, then your red remains untouched. If it was blue you picked the first time, your red remains untouched. So your red will still be 5, but the total is 11 because there was no replacement of that first ball you picked. So total has dropped to 11. Then it now says if it was blue you picked that first time, then probability of picking a blue the second time, since the first was a blue and you didn't replace it back, your blue must have dropped to 6 and the total dropped to 11. So probability of picking a blue a second time is now 6/11. So you see, they are done independently like that. Then this first part is saying red. If it was red, you picked the first time, 5/12. If it was blue, you picked the first time, 7/12. So that's the first pick. Then a second pick, you now have 2 branches for red, 2 branches for blue. So do you guys understand this properly? Okay, so this is selection without replacement. So before we go, I'll quickly want you guys to fill out. And for the other part, you already know what to do. After you're picking both red, 5/12 times 4/11. Red and red, you can see there. Probably that the first is red and the second is a blue. So you're multiplying red times blue. That's 5/12 times 7/11. Probability that the both of them are blue, you can see there, 7/12 times 6/11. So just the same stuff you did in the first part with replacement. That's the same thing you do here. The only difference is that the figures, the probabilities in the without replacement, you can see for with replacement, see all the numbers are just the same. That's why I told you it is too direct and shouldn't be expected to be seen in an exam because it's just too direct. All numbers retain same value. That's with replacement. But without replacement, you would have to think to be able to know what should be there. So that's why this is what you should expect. If a question like this is to come, it is without replacement, definitely without replacement. So that's by the way. Now we'll quickly take a question. I'll just expect you guys to fill the box. You take it one question each. So I'll just say I'll just say 10 white and 3 yellow without replacement. So now I want you guys to complete this table. 10 white and 3 yellow without replacement. So a first ball was picked and the second was picked. So I'll just draw the table and I want you guys to complete it. You tell me what to write. So let's say this is for white, this is for yellow. So here I'll have 2 branches for my second pick. So here, this is the first time you picked. That's the first time. Then for this other side, it is the second time you, oh, this other side is the second time you pick. So first pick, second pick. The first pick is the first one. The second one gives, you have 2 branches for each. So this is still white, this is yellow, this is white, and then this is yellow. All right. So who's taking the first one? Lucas, if it was white I picked the first time, what's the probability? Remember, 10 white, 3 yellow. So you have to find the total first. So if it was white I picked the first time, Lucas, what's the probability for white?
10/13.
10 over 13. 10 over 13. That 13 is ugly. And this one is fine. Okay. Christine. Oh, let me check if other persons have joined. Lucas, Christine. Winner network, it's glitchy. Christine, if it was white I picked the first time, what's the probability that, and what about picking white yellow the first time? We're still in the first pick.
Three.
In
Three
the
out of 13.
okay, 3 out of 13. 3 out of 13. So this is for the first pick. If I pick white, 10 out of 13. If I pick yellow, 3 out of 13. All right, Lucas, your turn. Oh, winner, can you hear us? So late, I don't know. All right, Lucas, back to you. Now, if it was white you picked the first time, remember without replacement. If it was white you picked the first time, probability that the second time it's a white. That means you are fill this place, purple, fill in this purple space. What should be there? Lucas, that's
Now
your turn.
over
9 over what?
12.
Okay, 9 over 12. 9 over 12. 9 over 12. Okay, now, Christine, your turn. Remember, don't look at this. Don't look, in short, don't let it be like this. Don't look at this bottom, that part. No, you're looking at what you're doing now. You're looking at the fact that if it was white I picked the first time, so forget about that other yellow at the bottom. That one is different. That's when you're saying if it was yellow I picked the first time. So now we're in white. So if it was white you picked the first time and then replace it, picking a white a second time is 9 out of 12 because you have picked one white before. So the white has reduced to 9 and total to 12. Now, if it was white you picked the first time, what is the probability of picking a yellow the second time?
Three out of 12.
3 out of 12. So yellow, 3 out of 12. Because you've not touched the yellow. Since you picked white the first time, the yellow remains the same. It's untouched. So yellow remains 3, but the total has dropped to 12 since You didn't replace the first one. All right, so we are done with the part where we are saying that if it was white, we picked the first time. Now we progress to if it was yellow, we picked the first time. And now when you're doing this, forget about that top. You're done with that picking white the first time. You're done with it. Do not look at that to try to ascertain what result you should have here. No, you're now dealing with yellow. You picked yellow the first time. So what is the probability? Lucas, it's your turn. You picked yellow the first time. What is the probability of picking white the second time?
10/12.
10 over 12. So here you have 10, oh, 10 over 12. That's because if you picked yellow the first time, so your white should be untouched. So the white remains exact 10, but the total is reduced to 12. You can see that all the numbers are just changing. They're different. Unlike the other one that with replacement, everything is just the same. So that's why they mostly prefer to give you this rather than with replacement that is straightforward. Okay, so Christian, you're taking the last one. If it was yellow you picked the first time, probability of picking yellow the second time would be what? Without replacement.
3/12.
Nope. You picked yellow the first time. This is the part you're feeling this part here. You picked yellow the first time without replacing it. What's the probability that you will pick yellow the second time? Or didn't I hear you well? You said 3 over 12. Wasn't that what you said? 3 over 12.
Yes, sir.
Yeah, so that was wrong. I was thinking if I didn't hear you well. So that was wrong. Think you picked yellow the first time and you did not replace it. What's the probability of picking yellow a second time? If you picked yellow the first time, does a yellow and you didn't replace it, does a yellow still remain 3 by the second time you want to pick yellow?
No, sir.
So what should that probability be of picking yellow the second time?
2/12.
So that should be 2 because you picked yellow the first time and you didn't replace it. So picking yellow the second time would be 2 out of 12. That's 2 out of 12. So this is the tree diagram. This is what we call the tree diagram for probability with replacement, and there's probability without replacement, of which this one without replacement is the most recurring questions. Then if you're told probability of that both of them are white, then you already know what to do. That you can see the white and white there, 10 over 13 times, and means times, that the both is white and the second is white. So 10 over 13 times 9 over 12. If you're told probability that one is white, the other is yellow. Probability that one is white, the other is yellow. In that case, you have to say it is white and yellow or yellow and white. White and yellow, that's 10 over 13 times 3 over 12, or which means plus yellow and white, which will be 3 over 13 times 10 over 12. That's when you're told that one is white, the other is yellow. But if you're now told that one is white, the other is yellow, in that order. In that order. That means you're only taking white and yellow alone. In that order means in that arrangement, meaning the first one was white, the second one is yellow. So yeah, another way they can give you that question without saying in that order is they might say find the probability that the first is white and the second is yellow. So that way you already know that they're saying the first is white, second is yellow. So white, yellow, that's WY. 10 over 13 times 3 over 12. First is white, second is yellow. But if it is just find the probability that one is white and the other yellow, in that case, there are two cases and where you're having white and yellow together. So that's when you say white and yellow, or that's plus yellow and white. Then probability that they're both yellow, you already know what to do. 3 over 13 times 2 over 12. So just like that, anyhow the question comes, should be able to. Yeah, so this is a tree diagram. This is what is called a tree diagram. Do you guys understand this topic very well? All right. So this is where we are ending the probability as well as today's class. I think next week is the. I think next week that's when you're having the last class for the month. So we'll pick out another topic that is very or you guys, it could just even be a random class. You guys can ask your questions from maybe places where you've had questions and where you're studying. Yeah, we can do that as well. But I'd like to look at logarithm by the next time. Logarithm, not those logarithm, change of base, and how to work with logarithm. I think that would be a good topic to look at from next week. So this is the end of probability for now. If there are no questions, then we're ending the class here. Do you have questions? Okay, so in the absence of any question, we'll end the class here. So bye for now and take care of yourself. And I'm wishing you guys success in your exams.
All right, sir. Thank you.
Thank you, sir.
All right, bye.